Hey everyone, and welcome. Today we're going to pull back the curtain on one of the most important but kind of invisible technologies that powers our digital world, virtualization. It really is the secret sauce behind the cloud, and by the end of this, you'll see exactly how it all works. All right, so let's just jump right in with a big question. We all hear about these massive data centers, right? But how do they work so efficiently? How is it possible for one single physical computer to act like it's dozens of different computers all at the same time? Well, the answer is virtualization. And here's the crazy part. You're already using this stuff all the time, probably without even realizing it. Every single time you stream a movie, check your email, or save a photo to the cloud, yep, you're tapping into a virtualized environment. It is the backbone of pretty much everything we do online today.
So let's define this thing. At its very core, virtualization is the process of using software to create a virtual version of something physical. It's software that cleverly takes one physical computer's resources, its processor, its memory, its storage, and divides them up into multiple totally separate virtual computers. Basically, it lets one powerful machine do the job of many.
So here's what we're going to cover. First, we'll nail down the basic concept. Then we'll look at the magic software that makes it all happen. After that, we'll dive into the most common types. And finally, we'll see why this technology completely changed the game for IT. Okay, so to really get why virtualization is such a big deal, we got to take a quick look back at how things used to be.
It wasn't that long ago that if you had an application, you had to have a dedicated physical server just for that one app. This one app per server world meant companies had entire rooms packed with servers, and most of them were just sitting there, using maybe 5 or 10% of their actual power. It was incredibly expensive, wasted a ton of space and electricity, and honestly, it was a nightmare to manage.
So, what was the big breakthrough? How did we get out of that one-to-one mess? Well, the answer lies in this amazing piece of software called a hypervisor.
The hypervisor is the absolute engine of virtualization. Think of it like a traffic cop for the physical server's resources. It's this thin layer of software that sits between the hardware and your virtual machines, and it slices up all the physical resources, the CPU, the memory, the storage, and hands them out to multiple independent virtual machines, or VMs. And crucially, it makes sure that none of these VMs can mess with each other.
Now, it's important to know there are two main flavors of hypervisors. First, you have Type 1, or bare metal. This one gets installed directly onto the server hardware, which makes it super fast and super secure. This is the one you'll find in almost every data center. Then you've got Type 2, the hosted kind. This one actually runs like a regular app on top of an operating system you already have, like Windows or Mac OS. This is perfect for developers or anyone who wants to, say, run Linux on their Windows PC for testing.
All right, let's talk about the big one, server virtualization. This is really where the revolution began, and it's all about doing way more with less.
And there are a few different approaches here, each with its own trade-offs. With full virtualization, you basically trick an operating system into thinking it has its own dedicated hardware. It doesn't need any special modifications, which makes it awesome for running older legacy applications. With para-virtualization, the operating system actually knows it's a guest and cooperates with the hypervisor. This gives it a nice little performance boost. But the real game changer today is OS-level virtualization, which you probably know by another name, containers. Instead of pretending to be hardware, containers just share the host computer's operating system kernel. This makes them incredibly light and incredibly fast. We're talking about tools like Docker, which are the foundation of modern software development.
But hey, it doesn't stop with servers. This whole idea of separating software from hardware, well, it's been applied to pretty much everything in a modern data center.
Let's talk about storage. Storage virtualization is all about pooling a bunch of different physical storage devices and making them look like one giant, easy-to-manage hard drive. And a really good way to get your head around the two main types is to think about a warehouse. So, on one hand, you have block storage. This is like your perfectly organized warehouse with neatly labeled and numbered bins. Access is very fast and direct, which is exactly what you need for things like databases that need top-tier performance. On the other hand, you've got object storage. This is less like a warehouse and more like a massive public library. Every file is an object, kind of like a book, with its own unique ID number. You don't care where it is on the shelf, you just ask the librarian for it by its ID. This approach is endlessly scalable, making it perfect for the massive amounts of data we have today, like all our photos, videos, and backups.
Next up, the network itself. Network virtualization lets you build an entire complex computer network completely in software. Imagine drawing out your network with all its switches, routers, and firewalls on a screen instead of physically plugging in a bunch of cables. It gives you an unbelievable amount of flexibility and makes security so much easier to manage.
And get this, we can even virtualize your entire desktop computer. It's called VDI, or Virtual Desktop Infrastructure. Your personal desktop, your operating system, your apps, your files, it all lives safely on a server in a data center. This means you can log in and get your exact work environment from any device anywhere in the world. This has been a huge deal for remote work and for keeping company data secure.
And finally, we can even virtualize individual applications. This separates the app from the operating system it's running on. So an app can be streamed to you from a server with little bits sent down as you need them. Or it can run completely on the server and you just see the screen. Or it can be packaged up in its own little bubble so that it can run on any computer without needing to be installed. This is how you can do cool things like run a Windows-only program on a Mac.
Okay, so we've covered the what and the how. Let's wrap things up by talking about the why. Why does all of this matter so much?
The impact here is just huge. You get incredibly efficient use of your hardware, which leads to massive cost savings on equipment and electricity. Disaster recovery is way faster because you can just move or copy a virtual machine to new hardware in minutes. Businesses can move faster, spinning up new servers for development or testing in seconds instead of waiting weeks for a physical machine. And because every VM is totally isolated from the others, it's a big boost for security.
And we're not talking small change here with the cost savings. One study actually found that virtualization can slash the total cost of ownership for IT by an average of a whopping 62%. That's from buying less hardware, using less power, and just making everything easier to manage.
Look, if there is one thing you take away from all this, let it be this. Virtualization is what makes the cloud possible. It is the engine. When you go to Amazon Web Services or Google Cloud and you spin up a new server, you're not getting a physical metal box. You're getting a virtual machine, one that was just carved out of their gigantic virtualized data centers. That is what gives the cloud its incredible scale, speed, and flexibility.
By turning physical hardware into something that's defined purely by software, virtualization completely rewrote the rules of computing. It laid the foundation for the cloud, for containers, for basically everything that's come since. So the big question now is, as we continue to turn more and more of our physical world into code, what's the next great transformation going to be? Thanks for watching.